Okay, let's go. We're going. Okay, and action.
Okay, thank you.
Pain in the butt.
So,
That's what it is.
well, now we got that on there. This is the day that Taylor saw a mountain lion, okay, or the day after, all right? So we just have it now, we have on videotape. Okay? This is section 2.5, linear, quadratic, and rational inequalities. The problem with this is we've crashed all of them into one section, which is, last year was 3 sections, so you don't have to move. I'll get over there in a minute. So what I would want you to do is we're going to just look at examples today, but we're going to talk about inequalities. One thing I want to point out, in an inequality, they're just like equations most of the time, except for with normal inequalities. Now when we get to compound and things, those are a little different. But the one thing I want you to remember is if you multiply or divide by a negative number, you must switch the inequality sign.
Is there a reason for that, or is?
Yeah, I mean, I did example to give you an example. If you have 5 is less than 6, right, Trevor?
Yeah.
Okay. Okay. So if we were to divide both of them, or let's multiply by a negative because it's easier to multiply. Is this a true statement?
Yeah.
Okay. So let's multiply both of them by a -2, Trevor. Okay. So now we have a -10 is less than a -12. Is that true? No. Mysteriously, the -10 is
Greater than.
yeah, is greater than, and that's why we have to. Our rules of multiplication, because of negative numbers in our rules, changes it, doesn't it?
Alright.
So that's why that works. Okay, addition, it doesn't matter. Subtraction, it doesn't matter. Okay, so that's the first thing you have to remember. The second thing is we're going to talk about interval notation again. You've had it last year, right? But I think we need to review it a little bit. Interval notation, remember that parentheses means that I touch it, or I don't touch it, and a bracket means I do touch it, okay? And then, for example, let's say that I have a graph, and I get x is greater than 6. You remember that? Okay, well, interval notation is, if I graph it, we're going to use the graph of I'm going to put 6 somewhere in the middle, 7 and 5, and I'm not touching 6, am I? Okay, so what I do is I use a parentheses and then I shade it. This is what we call, this is called set builder. Do you remember that? This is called set builder notation.
And the parenthesis always goes the same way as your shading?
Yes.
Okay.
Yes. Yeah, so it curls towards the shading. Yeah.
Okay.
It's like you're keeping it, right? Okay. Then this is set builder. Let me show you interval. Interval notation. Remember, this would be an open dot arrow, right? If we graph this the old way, it'd be an open circle here, and then we'd shade it. Do you remember that? I don't know if you've seen that, Cole. Okay, but interval notation is a parentheses. And to write it out, we go parentheses 6 to infinity parentheses. The 6 has a parentheses because it doesn't touch it. And the infinity has a parentheses because you can't touch infinity. Okay, all right? Now, if this was greater than or equal to, this becomes a bracket, and this becomes a bracket. But this will stay a parentheses. Okay? All right? And as we go through, and do these problems, you can ask questions on it when we do them. But let's take a look at an inequality that you would have to do. Number 1. You want to solve. The directions will say solve. So we have a -2y minus 3 is less than or equal to 7. Okay. All right. So the first thing that we're going to do, it's a 2-stepper. We're going to subtract a -3 from both sides or add 3 to both sides. It's up to you. I'm going to go plus a negative because that's the way I teach it in junior high. So a -2y plus a -3 minus a -3 is less than or equal to 7 minus -3. Notice I do not switch the sign. I do not switch the sign because I am subtracting negative 3. It has nothing to do with multiplication or division. Over here I get a negative 2y is less than or equal to. This is 10. Is everybody with me that far? This is the place that I have to look at where if I switch the inequality sign. I'm going to divide both sides by a negative 2, right?
Yeah.
Now I'm dividing by. If this is a positive 2 and this is a negative 2, I don't switch the sign. You can divide into a negative, but you can't divide by a negative. Do you understand the difference? Okay, so when I do this, I'm going to take a negative 2y divided by negative 2, and I'm going to switch the inequality sign. Okay, so I have 10 over negative 2. Correct? All right, so now I have y is greater than or equal to a negative 5. That is somewhat set builder form. I don't want it like that. It says to graph it, so we're going to put a negative 5 in the middle. That's why I do it. Negative 4 on this side, negative 3 on this side. And I'm going to put a bracket, and I'm going is greater than negative 5, so I'm going that way. So my bracket opens up.
It'd be a negative 6, not a negative 3.
Oh, thank you. Got that on tape, didn't you? All right, good. Thank you. I was wondering why it got so quieter than it normally. So I put a bracket here and I shade, right? Like that. And so my notation is bracket a negative 5 infinity parentheses. Cole, do you have any questions about that?
Not yet.
Not yet. Okay. All right. Well, let me know if you do. Any of you, please. 3 times 2x minus 4 minus 7x is less than or equal to negative 3x. Okay. Now, I may not do this one. Yep.
So you don't want us to put it in set builder?
No. Let's just go all interval. Okay? Yep. And, this is good for Laney to see who's back there because, I taught them interval notation too, and I think sometimes they go, well, why are we learning this? Well, now they've got it learned already, so that this year it's going to be a lot much easier to relearn it. It's always easier to relearn than it is to learn it again. Go through it, I'm going to change all subtraction to addition. And then I'm going to distribute, what?
Nothing, just something you said.
Okay, distribute it through. Okay, 6x plus a negative 12 plus a negative 7x. If I go too fast, let me know. Remember, I'm not going to do this how you would do it because I want to show you something. Okay, so I got a negative x. If you add these two, you get a negative x plus a negative 12 is less than or equal to a negative 3x. Okay, some of you would subtract a negative 12 from both sides. I'm actually going to subtract a negative x because I'm going to put it on the right side for a reason. Okay, so I'm going to subtract a negative x from both sides. So I get a negative 12 is less than or equal to a negative 2x. Okay. And then I'm going to divide by.
Negative 2.
And since I'm dividing, it has nothing to do with this negative. It has everything to do with this negative. So I'm going to divide by a negative 2. And notice I switched the sign. Whatever the sign is, just switch it. So what I get is 6 is greater than or equal to x. Okay? To me, that is very difficult to do. And I would not want your answer like that. Even in set builder notation, I would ask that you put the x on the left side. And so what I'm asking you to do is to rewrite this. Now, did I switch the sign there? Kids always say, well, you switched the sign. I did not switch the sign. Logically, this and this are the same. Whereas up here, logically, when I switch a sign, this is not the same. Okay, so I did not switch the sign. What I did was I wrote it so the x is on the left. My opinion is your x should be on the left. It's much easier to deal with. Okay, so then I have 6 in the middle and 7 here and 5. And I have a bracket because it's greater than or equal to, and I'm going left. And so watch now how it changes the interval notation. I always read left to right, right? I always read left to right, correct.
Yes.
All right, so left is
Negative infinity.
negative infinity. So I cannot touch a negative infinity, and I go to a negative 6, and I bracket it because I'm touching. But notice the infinity switch sides because I'm reading left to right. On this one, I read left to right, and I ran into the graph at a -5 first, and then went to infinity. Did I screw up again?
What
It's
is
supposed to be a positive 6.
What is this?
It's your bracket.
Thank you. What? All right. Okay. All right. It's that mountain lion. It kind of got me rattled. That's it. Maybe our mascot should have been that, right? It rattled the opponents. I did. Bobcat's just not scary enough. Yes, I know. All right. You understand just normal inequalities, okay? Well, then we're going to jump to compound inequalities.
Yeah.
Well, it gets worse because we're going quadratic and then rational. So, yeah. So you can squeal all you want, little piggies, but it's not going to help. All right. Compound inequalities are and or, and they help us with absolute values. So it's really important that you learn these. Okay. We have a union and an intersection. Okay. We've had this before, so I'm going to jump a little bit. I'm going to show you this one. Okay? If you're following along in the book, I just did a big jump there. Okay? Is this an and or an or?
And
This is an and. How come it's an and? How do you
because
know?
it doesn't have the word or. in
All
it.
right. In order to be an or, it has to have the word or. Everything else is and. Okay? So this is an and. So this is what we call an intersection. Okay? I'm just going to write this off to the side so you know. This is an intersection which uses this symbol. I mean, that's the intersection symbol. Okay? All right. So I want to split this up, and this is related to both sides. So I'm going to go a -3 is less than or equal to 2x minus 5, and I'm going to physically put the word and in. 2x minus 5 is less than or equal to 3. I think it's important that you put the word and in, so you understand that it is an and, it's an intersection, it's not an or. And I'm going to go ahead and solve. Just like you would a normal inequality, like you would over here. Only you have two of them. So I'm going to subtract a -5 from both sides. And this is 2. And I'm going to end up dividing by 2 here. Do I switch the sign?
No.
No. So I have x is greater than, or 1 is less than or equal to x. I'm going to go ahead and switch it around. X is greater than or equal to 1. I really feel like you need to put that on the left side for you to understand logically what is going on. Questions? You have a question? Okay, good. And on the other side, I'm going to go plus a negative. So 2x plus a -5 minus a -5 is less than or equal to 3 minus -5. So 2x is less than or equal to 8. And I'm going to divide by 2. I get x is less than 4. Okay. Now, this better intersect, correct? Okay, this better intersect. Because if it doesn't, we're in trouble. So I use the combination of both, and I don't know if this is the right way to do it, but I'm going from 1 to 4 on my graph, so I'm going to go from 0 to 5. And this is where I've had trouble today graphing, so keep an eye on me, just to make sure. Now, intersections are supposed to have points that are together, right? So if one starts here and goes this way, and one starts here and goes that way, we have no solution. Do you understand that? That's a union. But we're hoping that they go the same way. And I'm going to go back to the old days where I did this. You remember this? And I just think this is quicker for us in this case. You can use the new method. Is that part of my answer? No, this is not part of my answer, so you can choose whatever you want. If you want to use interval notation to graph that, that's wonderful. But you don't have to. Okay? And so what happens is I have an intersection from here to here, right? From here to here, 4, sorry, here to here. So and they're touching. So I go bracket here, and I shade what's in between. So I do the same with my answer. So it looks like that. I'm going from 1 to 4, and I'm including 1 to 4. Does that make sense? You good? All right. Okay. So we've done an and. What's the other one?
Or.
It's an or, and it's a union. So let's look at this one. How do you tell an or? It has the word or in it. This is number 4. It has the word or in it, so it'd be like 3x plus 7 is less than or equal to a negative 4, or 3x plus 7 is greater than or equal to 4. And it's an or, okay? And it's already split up for you, so you don't have to split anything up. I will write that this is a union, and so we have a U. I mean, that's the symbol we use for a union. So I just go ahead and solve it just like normal. 3x plus 7 minus 7 is less than or equal to a negative 4 minus 7. So 3x is less than or equal to a negative 11. This is not going to be pretty. Now, do I switch the sign here when I divide by 3? No, I'm dividing into negative 11, but that doesn't matter because I'm dividing into it. So I have 3x divided by 3 is less than or equal to 11 divided by 3. So x is less than or equal to, I'm going to change it to 3 2/3 for right now, just so I know how to graph it. Okay? We good? I'll go ahead and do the other one. So I have 3x plus 7 minus 7 is greater than or equal to 4 minus 7. So 3x is greater than or equal to a negative 3. Once again, since I'm dividing by a positive into a negative, it doesn't matter. Thank you, Lainey. Was it good? Mm-hmm. All right, good. All right. So 3x divided by 3 is greater than or equal to a negative 3 divided by 3. So x is greater than or equal to a negative 1. Okay? Now, I'm just going to take a look at this on a graph. This is, I'm going to go from a negative 4 to a negative, or to 0. All right. And so this one says that I'm going to go left here. So I'm going to start here and I'm going to go this way. And this one says that I'm going to go, and I can put it at top or bottom. I'll go ahead and put it on bottom just to keep it the same as that one over there. And it goes like that. And that is a union. That's basically, now if this is an intersection, if this is an and, I have a no solution, right? If this is an and. What if this one went this way? Then I would start here and take all of those points. Because you want the whole thing. I want both of them together. What's really weird is when this one goes this way and this one goes that way, then it's all real numbers. Because it includes the whole graph.
Only on ors though, right?
Only on ors. Ands are a total different. Yep, that's a great. So I'm going to take a bracket here and shade this way.